All right, so we need to be on page 399, and today we're going to focus on finding part of the whole. But that's not all that we're going to be doing. According to the TEKS here, we should be able to find out what the whole is given the part and the percent, find out the part given the whole and the percent, and to find the percent given the part and the whole. Okay, so in this particular situation, we have 200 students who chose their favorite snacks in a survey. The table is not complete, so we have to complete the table. Now the first line is complete, so we have fruit. 23% of the students liked fruit, and so the fraction is 23 hundredths because percent means out of 100. If there are 200 students, then we're going to make 200 the denominator here. And so to make 200 out of 100, we multiply by what number? That's correct, we multiply by 2. So if we multiply 23 by 2, we're doubling 23. 20 plus 20 is 40. 3 plus 3 is 6. That means 46 kids out of 200 is equivalent to 23%. Those are the kids that liked fruit. So let's go ahead and do the same thing with 15. So what number should be in the numerator? Answer that for me, please. That's correct. We should have 15 as the numerator because 15% is 15 compared to 100. So if we were to find the equivalent fraction, we are still multiplying by 2. 100 times 2 is 200. So what is 15 times 2? Very good. That number is 30. And so that means that 30 children out of 200 like cheese. And if you notice down here that there's also another 15%, so we're going to go ahead and write 15 out of 100 here. And that's going to be 30 out of 200. And then we have 30 students that liked cookies also. All right, so if we were to write the fraction for 17%, it's going to be what number over 100? Okay, I want you to go ahead and tell me by figuring out the next two blanks on your own, how many students liked veggies? Go ahead and do that for me, please. Okay, if you said 34, you're correct, and you should be writing notes. So I will be asking you to open up your books tomorrow and show me that you've done what if I write, you write. Okay, 17 doubled. 10 plus 10 is 20. 7 plus 7 is 14. 20 plus 14 is 34, so that is the correct number. Let's go ahead and do 18. I want you to fill in all three blanks for me. First off, what number should be in the numerator of this first fraction? That's correct. That's going to be 18 out of 100. So 18 is the numerator. And then go ahead and find the equivalent fraction, and then how many students, answer this question, how many students preferred chips as their snack? If you said 36%, you're correct because 18 plus 18 is 36. 10 plus 10 is 20. 8 plus 8 is 16. 20 plus 16 is 36. And then finally, how many students didn't have a snack? All right, hopefully you said 24. Now, how do we know that we're right? So if it's 46 out of 200, 30 out of 200, we need to be able to add all of these numbers together and get the number 200. So let's go ahead and see if that's true. Okay, that definitely is true. 30, 24, 30, 36, 24 plus 46, all these together do equal 200. So in this situation, when we are given the whole, which was 200 students, and a percent, we found the part. So we're going to do the other versions for practice on the next pages. Continue to write notes. If I write, you write, please. Thank you. Okay, on this page it says you can find real-world problems. You can solve real-world problems to find part given the whole and the percent. To do this, you can use models. You can also express the percent as a fraction or decimal to show an equivalent part of the same whole. In this first picture here, we have a circle diagram, and the whole circle equals 100%, so all these parts equal 100%. So let's suppose there are 300 students and they each have a preference for snacks. We want to find out how many students like cheese as a snack. It says 15% up here. All right, so they have drawn a strip diagram, which we looked at the other day. So it's a strip diagram The top is considered a number line. We're going to skip count by the benchmark fraction. 15% is in between 10% and 20%, so they've skip counted the top by 10%. So there are 10 sections, each of them worth 10%. Now the bottom, the whole of the 100% is equal to 300 students, and so they took the number 300, divided it by 10, and skip counted by 30. And you can see 15 is halfway between 10% and 20%, so they calculated that halfway between 30 and 60 is 45. Well, let's use the same method that we used on the previous page and see if we agree with this answer. So if we have 15%, isn't that the same as 15 over 100? And if there are 300 students, what do we multiply 100 by to get to 300? That's correct, 3. So what is 15 times 3? So off to the side, you're just going to jot 15 times 3, and you end up with what? 45. And we do agree the exact same way they found the model. Now, they did the method 2, they did it slightly differently. So instead of taking 15 over 100 and making it to 300, they reduced it by dividing 15 hundredths by what number? 3 times what is 15? 20 times what is 100? Answer that for me, please. That's correct. They divided by 5. And once they divided by 5, here's something we need to understand. If we multiply the fraction equivalent to the percent by the whole, we end up with the part. So here's the part multiplied by the whole, and we end up with 45. So let's try this. What is 3 times 300? Answer that, please. Okay, 300, 600. The answer is 900. Okay, so we end up with 900 on top. And what is 20 and times 1? The answer is 20. So we end up with a really crazy improper fraction. In order to solve that, we would actually divide 900. In this case, the numerator is larger than the denominator, and that's okay. The denominator is the divisor, so we're going to ask ourselves, how many times can 90 go into, how many times can 20 go into 90? That's correct, 4. And 4 times 20 is 80. If we subtract that, we get 10. We bring the 0 down. And as you can see, what times 20 is 100? The answer is 5. There is 45 students. We got it that other way as well. There are definitely more than one way to solve these problems. On the next two examples, it says percents greater than 100% and less than 1%. So you can choose which strategy you want to use. Now, I think the strategy I use for 2 is a little bit nutty, but we're going to go ahead and talk our way through it. And I think that it's actually easier to apply the strategy they use for 3 to the second example. It says determine 145% of 320. So they've made 125% into the percent fraction, 145 over 100. And then they simplified it by dividing the top number and the bottom number by what number? 20 times what equals 100? Exactly, 5. 145 divided by 5 is 29. So they have 29 20ths, and then they multiply that by the whole number. 29 times, well, actually what they did was they reduced it first. So they said, okay, you have 20, we have 320. We can actually divide 20 by 20 and get 1. We can divide 320 and get 16. And so they end up multiplying 29 times 16 and get 464. All right, but I'd rather prove that by using the method that we've used down here. And so basically 145% is the same as 100%. So this is 100%. And 100% of 320 is 320. And then we have plus 45%. Okay, so 45%. We have to now figure out what 45% of 320 is. And so that automatically makes it smaller problem to solve. So we say 45 over 100, and we're going to multiply that by 320. Okay. Let's simplify this. What can I divide the top number and the bottom number by? Well, this ends with 5 and this ends with 0. So what number can go into both? That's correct, 5. So this is going to be 9. And 100 divided by 5 is 20. Okay. So we have 320 and we have 20. And we could definitely reduce this. How could we reduce this? Well, can't we divide the top number and the bottom number by 10? So if I do that, I end up with just 2, right? And 320 divided by 10 is 32. What is 32 divided by 2? Well, what is half of 32? That answer is 16, and you could write it out long division if you want. So all we have to do now is multiply 16 times 9. Go ahead and solve that for me. What is 16 times 9? Okay, 6 times 9 is 54. And 9 times 1 is 9, plus 5 is 14. So we have 144. My pen's doing crazy stuff. Sorry about that. So 45% of 320 is 144. All we have to do now is add 144 plus 320, and that is going to get us 464. So if I go ahead and line this up right underneath it, it's not like the pen's running out of ink. I do not know why it goes crazy. Okay. So 2 plus 4 is 6, and then we end up with 464 like that. Okay. So that's how you do problems that are involving something larger than 100%. Finally, this last example is, what do you do when the number... Why does it still say Google there? Oh, that's crazy. Okay, what do you do when the number is less than 1%? So it shows you that 25 hundredths percent is equivalent to this decimal. How did we get that? Going from percent to decimal, you're supposed to move the decimal point to the left or the right. Answer that for me. Yes, you move it to the left 2 spaces. So if you have 0.25, which is 25 hundredths, which my pen went crazy again. So if you have 25 hundredths and you move it 2 spaces to the left, you end up having to fill in these spaces with zeros. Okay. Then you'd multiply. So now you have a decimal point. Instead of setting up like fractions, dividing or multiplying the whole number by the fraction, you can multiply the whole number by the decimal. This might be a little scary for some of us because we only encountered this last year, but basically you just line them up and you multiply 58 times 25 10,000ths. Okay, so do not panic because you can just ignore the decimal for right now and act like you're just multiplying 58 times 25. So go ahead and do that for me. Multiply 58 times 25. Okay, so we've multiplied this and we got 1,450, but because this really isn't 58 times 25, it's 58 times 25 10,000ths, we now have to move the decimal. Currently, the decimal is here. We have to move it 1, 2, 3, 4 spaces to the left. So 1, 2, 3, 4. And so that's how this decimal got to be in front of the 1. So the answer is going to be 145 thousandths. Okay, so we're going to do some guided practice together, and then you'll have some independent practice to do, and whatever you do not finish in class will be homework. Thank you for taking notes.